There are several potential reasons why the Postal Service might not mandate licensing or permits for its electricians. Firstly, consider sovereign immunity. As a federal entity, the Postal Service operates under federal law, which supersedes state and local regulations, including those governing electrician licensing. This principle stems from the Supremacy Clause of the United States Constitution. Secondly, the absence of federal law mandating electrician licensing plays a role. While the Occupational Safety and Health Administration, or OSHA, sets electrical safety regulations, these do not explicitly require electricians to hold licenses. Thirdly, cost considerations may influence the Postal Service's decision. Licensing can be an expensive undertaking, and the Postal Service may seek to avoid the financial burden of licensing all its electricians. Fourthly, the Postal Service may have confidence in the expertise of its in-house electricians. They provide their own training programs, believing these adequately prepare their electricians for the tasks they undertake. It's important to understand that not requiring licenses does not automatically equate to unqualified electricians. The Postal Service maintains internal standards for electrical safety, and their electricians must adhere to these standards to work on electrical systems. Ultimately, the decision to mandate licensing is a policy choice for each state or agency. The Postal Service has decided it does not need to require licensing for its electricians, a decision it is legally entitled to make. In the context of electrical safety, it's important to understand some fundamental concepts. Electrical current flows through a conductor, such as a wire, when there is a difference in electrical potential, measured in volts, between 2 points. This flow of current is measured in amps. Resistance, measured in ohms, opposes the flow of current. These three quantities are related by Ohm's law, which states that voltage equals current multiplied by resistance. When working with electrical systems, it is imperative to follow safety precautions to prevent electrical shock and other hazards. These precautions include wearing appropriate personal protective equipment such as insulated gloves and safety glasses, and energizing circuits before working on them. De-energizing a circuit means turning off the power at the source, such as a circuit breaker or switch, and verifying that the circuit is indeed de-energized using a voltage tester. It is also important to follow the National Electrical Code, or NEC, which provides guidelines for safe electrical installations. The NEC is a comprehensive set of standards that covers everything from wiring methods to grounding and bonding. Grounding and bonding are essential for electrical safety because they provide a path for fault current to flow back to the source, tripping a circuit breaker and preventing electrical shock. Grounding refers to connecting a circuit or equipment to the earth, while bonding refers to connecting different metallic parts of an electrical system together to create a low impedance path for fault current. In addition to grounding and bonding, other safety measures include using ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electrical shock, such as bathrooms and kitchens. GFCIs are devices that detect small amounts of current leakage and trip the circuit, preventing electrical shock. It is also important to use arc fault circuit interrupters, or FSIs, in bedrooms and other areas where there is a risk of fire caused by arcing faults. FSIs are devices that detect arcing faults and trip the circuit, preventing fires. When working with electrical panels, it is important to follow proper procedures to avoid electrical shock. This includes wearing appropriate personal protective equipment, using insulated tools, and working with a qualified electrician if you are not comfortable working on electrical panels yourself. Electrical panels should be kept clean and free of obstructions, and all circuit breakers should be properly labeled. It is also important to periodically inspect electrical panels for signs of damage or wear. If you notice any problems, such as loose wires, burnt insulation, or corroded connections, you should have them repaired by a qualified electrician. When installing electrical wiring, it is important to use the correct size wire for the circuit. The size of the wire is determined by the amount of current that it will carry. The NEC provides tables that specify the minimum wire size for different ampacities. It is also important to use the correct type of wire for the application. For example, NM cable, or non-metallic sheathed cable, is commonly used for residential wiring, while THHN wire, or thermoplastic high heat resistant nylon coated wire, is commonly used for commercial and industrial wiring. When making electrical connections, it is important to use the correct type of connector. Wire connectors, such as wire nuts and crimp connectors, are used to join wires together. These connectors should be properly sized for the wires being connected and should be installed according to the manufacturer's instructions. It is also important to use the correct type of conduit for protecting electrical wiring. Conduit is a metal or plastic tube that is used to enclose and protect electrical wiring. Different types of conduit are used for different applications. For example, EMT, or electrical metallic tubing, is commonly used for indoor wiring, while rigid metal conduit, or RMC, is commonly used for outdoor wiring and for wiring in hazardous locations. When working with electrical equipment, it is important to follow the manufacturer's instructions. Electrical equipment, such as motors, transformers, and generators, should be installed and maintained according to the manufacturer's instructions. It is also important to periodically inspect electrical equipment for signs of damage or wear. If you notice any problems, you should have them repaired by a qualified electrician. In addition to following safety precautions and the NEC, it is also important to be aware of local electrical codes. Local electrical codes may be more stringent than the NEC, and they may require additional safety measures. It is important to check with your local building department to find out what electrical codes apply in your area. When working with electricity, it is always better to be safe than sorry. If you are not comfortable working on electrical systems yourself, you should hire a qualified electrician. A qualified electrician has the training and experience necessary to perform electrical work safely and correctly. They can also help you to ensure that your electrical system is up to code and that it meets your needs. Consider the implications of working with 480-volt systems. These systems are considered high voltage and require specific training and safety precautions. Working on such systems necessitates a thorough understanding of electrical safety principles and the use of specialized equipment. It is crucial to always energize the circuit before commencing any work and to verify the absence of voltage using appropriate testing equipment. Furthermore, using correctly rated personal protective equipment, including gloves, eye protection, and flame-resistant clothing, is paramount. Understanding the operation and maintenance of equipment connected to 480-volt systems, such as motors, transformers, and switchgear, is vital. These components have unique characteristics and require specific maintenance procedures to ensure their safe and reliable operation. Regular inspections, testing, and maintenance are necessary to identify and address potential problems before they lead to failures or safety hazards. Moreover, familiarity with applicable codes and standards, such as the National Electrical Code, is essential. These codes provide guidance on safe installation practices, wiring methods, and equipment selection. Adherence to these codes helps minimize the risk of electrical shock, fire, and other hazards. Additionally, specialized training courses and certifications are available for individuals working with 480-volt systems. These programs provide in-depth knowledge of electrical safety, troubleshooting techniques, and maintenance procedures. Completion of such training can significantly enhance one's competence and confidence in working with these systems. The information related to the Postal Service not needing electrical licenses may also be related to working in Wisconsin and Arizona. There could be other policies that may be different as well.